2021, grade 12, AMC 12B, fall questions 1 through 10. Problem number 1. What is the value of 1, 2, 3, 4 plus 2, 3, 4, 1 plus 3, 4, 1, 2 plus 4, 1, 2, 3? 1, 2, 3, 4, 2, 3, 4, 1, 3, 4, 1, 2, and 4, 1, 2, 3. So let's add this up. First, this guy, we've got 10. Then this looks like 11 to me. This looks like 11, and that is also 11. So 1, 1, 1, 1, 0, and that is E. Problem number 2. What is the area of the shaded figure? So it looks like we can take this full triangle and subtract from it this triangle. So the full one is 1/2 base times height, and the smaller one is 1/2 base times height also, but the dimensions obviously will be slightly different. So the first one, the base looks like it's 4 and the height is 5. For the smaller one, the base is again 4, but the height of the smaller one is only 2. So that looks like 20 minus 8 over 2, which is 12 over 2, which is equal to 6. So that makes this choice B. Problem number 3. At noon on a certain day, Minneapolis is n degrees warmer than St. Louis. At 4, the temperature in Minneapolis has fallen by 5 degrees, while the temperature in St. Louis has risen by 3 degrees, at which time the temperature in the two cities differ by 2 degrees. What is the product of all possible values of n? So we have Minneapolis, and we have St. Louis, and at noon, they are saying, we don't know the temperature, I'll just call it x. So it's x plus n, where St. Louis is at just x. And then at 4 p.m., it's 5 degrees less, so x plus n minus 5, and this is 3 degrees more. And then they're saying that the temperatures, if you were to compare them, differ by 3. Now, differ means it's either 3 more, it's either 2 more or 2 less. Now, we don't know which one, so I'm just going to put plus or minus 2. All right, so far so good. So now we have to solve this. So the good news is that the x's cancel. All you're left with is n minus 8 is equal to either 2 or n minus 8 is equal to negative 2. So solve these, and we get n is equal to 10 on this side, and this one gives me n is equal to 6. So these are the two possible values of n, and they want you to get the product of those two values. So 10 times 6 is the product, and that's 60. So C is the answer for 3. Let n be equal to 8 to the power of 2022. Which of the following is equal to n over 4? So n over 4 would be 8 to the power of 2022 over 4, obviously. So I think we're going to have to change the bases. The answers are all over the place. We got 4, 2, 8. So I'm not really sure which direction to go. Let's just use base 2 and then see what happens at the end. So if I do that, then I've got this 2022, but the 8 is 2 to the power 3, and the bottom is 2 to the power 2. So this top becomes 2 to the power of 6066, and the bottom is 2 to the power 2. So then combining exponents with exponent laws, you get 2 to the power of 6064. Okay, so that's about as far as I can get, and that is not one of the answers. So I guess I have to manipulate this. 2 to the power 2, 3032, and that's 4 to the power 3032. And let's see, is that one of the answers? And it is. It's E. Good. Problem number 7. Call a fraction a over b, not necessarily in simplest form. Special if a and b are positive integers whose sum is 15. How many distinct integers can be written as the sum of two not necessarily different special fractions? All right. So we've got A over B, and A plus B is equal to 15. So there's a lot. I guess we have A, we have B, and we have A over B. So 1 and 14, that would make this 1 over 14. 2 and 13, that would make this 2 over 13, and so on. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and then same thing, 1, 2, 3, 4, 5, 6. Well, let's see, I matched these up correctly. 7, 8, 9, 10, 11, 12. Okay, so this is, let's see if we can reduce these. 1 over 14, those two can't be, but this one, 3 over 12, is 1/4. But they're saying not necessarily in simplest form. Okay, but I'm going to reduce them anyways because it might be easier to add later. 5 over 10 is a half. 6 over 9, that's 2/3. 7 over 8. 8 over 7, 9 over 6, which is 3 over 2. 10 over 5, which is just 2. 11 over 4, 12 over 3, which is just 4. 13 over 2, and 14 over 1, which is just 14. Okay, so those are the possibilities for A over B. Now what they're saying is that you have to take two of these and add them. So, and then figure out how many distinct sums that you get. And they don't have to be different. That you can take this and add it to itself because it does not have to be distinct, not necessarily different. Okay, but the key word here is distinct integers. That's the key word in this question, that the sum has to be an integer. So if I added this guy to this guy, it may not be an integer, so that is not valid. Okay, so I'm going to try to concentrate on getting integers. And to get an integer sum, first I'll just concentrate on the integers, and that is this guy, and this guy. Those are integers, so obviously if I add them, let's look at the integer sums. So you can have either 2 plus 2, you can have either 2 plus 4, or 2 plus 14. You can have either 4 plus 14, or 4 plus 4, or 14 plus 14. Now those are all the possible combinations. So that's going to be 4, 6, 16, 18, 8, and 28. Okay, are they all distinct? 4, 6, 8, 16, yeah, they're distinct. So I've got 6 so far. Okay, 6 is not one of the answer choices, so that obviously means I got to keep going here. Okay, how else do I get integer sums like I did here? I got to use fractions with the same denominator. I'm pretty sure. Okay, so this is one of those cumbersome ones. Okay, so same denominator. Do we have any? Let's use a different color here. A half. There's a half in here somewhere, right? This one, yeah, there's a half. And there was a 3 over 2. And there's a 13 over 2, right? Yeah, right here, 13 over 2. Yeah. I think that's it. Okay, so let me just double check. Yeah. All right, so that means we're going to have either a half plus a half plus 3 over 2, a half plus 13 over 2. We can also have 3 over 2 plus 13 over 2, 3 over 2 plus 3 over 2, and then finally 13 over 2 plus 13 over 2. And this would give me 1, 2, and keep going. This is going to be 7, this is 8, this is 3, and this is 13. So again, we've got 6 of these guys. Now let's see if they're all distinct though. 1, 2, 3, 7, 8, 13. Okay. But hold on, this is a repeat because see there's an 8 there, and I think there, yeah, that's a repeat, so that cannot be counted since we only want distinct. Okay, is there any more? I think the whole common denominator thing is what we need to concentrate on. And And can we squeeze out any more? And I think we can with this guy here and the 11 over 4. If we use 1 over 4 plus 11 over 4, we get 12 over 4, and that is 3. We can get another integer, but the problem is this 3 is already counted, so we don't have a distinct. So in terms of distinct, it's just 1, 2, 3, 4, 5, 6, 7, 8, 9. Can't count that one. 10, 11. Can't count this one. So 11 distinct. So therefore, the answer is C. Problem number 6. The largest prime factor of 16384 is 2, because 16384 is 2 to the power of 14. What is the sum of the digits of the greatest prime factor that is a divisor of 16383? 16383. Okay, well, 16384, which is, I guess, one more, was 2 to the power of 14. So 16383 is one less than that, so it's 2 to the power of 14 minus 1. Okay, and this can factor, just like how you could factor a squared minus b squared to a minus b times a plus b. This factors 2 to the power of 7, 2 to the power of 7 minus 1 plus 1. Well, 2 to the power of 7 is a little bit more digestible, I think. What is that? Is it 128? Yeah, 128. So 128 minus 1 is 127. And then 128 plus 1 is 129. Now let's see. I think 127 is the prime number, because 129, I believe, is 3 times 43. So what is the sum of the digits of the greatest prime number that is a divisor of that? So the greatest prime number that is a divisor of that looks like 127 to me. And the sum of the digits, I guess, of 127 are 1 plus 2 plus 7, which is 10. So that would be C. Problem number 12. Which of the following conditions is sufficient to guarantee that x, y, and z satisfy this equation? This equation right here, I think we're going to need to manipulate it. So, let's see here. First, let's expand it out here. X squared minus xy plus y squared minus yz plus z squared minus xz is equal to 1. And what we're going to do is complete the square. And I hope you are familiar with completing the square. If you're not, just review it. It's fairly straightforward. So first we're going to do that there. So it's going to be x squared. Let's see here. Should I complete the square, or should I just kind of do something else here? I was thinking about completing the square, but let me see. I think I can, but it'll be in a non-traditional way. But let me just do it slowly to illustrate what's going on here. First thing I'm going to do is group these squareds together, x squared, y squared, z squared, and then group the other guys, the other sort of style of variables together, the xy, the yz, and the xz. And then I think to group this, I'm going to multiply through by 2. So everything becomes 2, 2, 2, 2, like that. And then this, of course, becomes a 2. Now I think I can group them. So if I have x squared minus 2xy plus y squared, you see what I did there? So I took this guy and I took just one of these and one of these. So that means I still have an x squared left over, and I still have a y squared left over from this guy and this guy. But then I've got the z's, so I can put one z here and one z here. That takes care of that. And then the minus 2yz I'll put here, and the minus 2xz I will put here. And then, of course, that all equals 2. And I think these work out to be perfect squares like this: x squared, x minus y squared, x minus z squared, and y minus z squared. Okay, so that works. Okay, so where do we go from here? Let's see here. Well, we are told that x, y, and z are integers, right? So if x, y, and z are integers, the only way that this plus this can be 2 is, like a scenario like this. This is 1 equal to 1, this is equal to 0, and this is equal to 1. You see what I mean? That would make it 1 plus 0 plus 1, which is 2. Because each of these has to be an integer. And that's just, there's kind of a limited options. And also these are squares, so we know that these are going to be positive integers. Well, positive or 0. Okay, well, if this is the scenario right here, then that basically means that x minus z is 0, so x is equal to z. Okay, that is good. And then it means that x minus y is equal to 1 from here. So that means, or it could mean that x minus y is equal to negative 1. Because remember, when you square it, it's going to become a 1. And from this, we can get that x is equal to y minus 1. I'm just trying to figure out something that matches the answer choices, and I think this does it. Yeah, x is equal to z, and x is equal to y minus 1. There we go. I just got it. Okay, great. Number 12, the answer is D. Problem number 8. The product of the lengths of the two congruent sides of an obtuse isosceles triangle is equal to the product of the base and twice the triangle's height to the base. What is the measure in degrees of the vertex angle of this triangle? Okay. Oh boy. All right, so let's just draw a basic diagram. It's isosceles, right? Okay. I'll just label this V, and I'll label the sides X. The height I will call H, and the base I will call B. Okay, let's see what's going on here. So they're saying that the length of the two congruent sides, so I guess that would be X times X, is equal to the product of the base, which is B, times twice the height. Okay, so that's my equation here. So I guess x squared is equal to 2bh. All right, so where do I go from here? Oh boy. I think we have to use trigonometry, because they're eventually asking about the degree of an angle. So that really makes me think trigonometry as soon as they start talking about angles. And they want the vertex of this angle. Okay. So you guys remember how to figure out the area of a triangle using trigonometry, right? Like, for example, if you had this is, say, A, B, C, and this is A in terms of the length, this is C, and this is B. The area of the triangle using trigonometry would be 1/2 side A times side B sine of angle C. Correct? So I think that's what we're going to have to use. And the area of this triangle here, without trigonometry, just using the 1/2 base times height, would be just 1/2 base times height. So I think that is what we have to do. So let me see here. X squared this, we can break it up into 4 and 1/2 base times height. That would be the equivalent of 2bh. Now the reason I did that is because this 1/2 base times height represents the area, and the area can be written there. So 1/2, but I have to use this triangle here, the dimensions. And which angle am I trying to figure out here? I'm trying to figure out the vertex, right? So I'm trying to figure out this angle. So let's see here. That would be 1/2 x times x sine of v. All right. Okay. So this becomes x squared. This is 2x squared sine of v. Okay. I see. The x squareds cancel. Because I thought there was way too many variables here. I was getting a little worried. Okay. Very good here. So then we just get sine of v as 1/2, and you guys know that. That's either 30 degrees or 150 degrees. Well, and there's more answers, of course, because as you guys remember, the sine graph is cyclic. It just keeps on going. but they want obtuse, right? Yeah, so obtuse, if I remember correctly, means what, greater than 90? So I should remember that. So that means 150. And 30 is not one of the answer choices anyways, so I don't think that you would be able to get tricked up there. So D is the answer for number 8. Problem number 9. Triangle ABC is equilateral with side length 6. Suppose that O is the center of the inscribed circle of this triangle. What is the area of the circle passing through AOC? Okay, oh boy. So I've got to let me first draw the diagram, and let's see what I can get here. Okay, so let's attempt to draw this without making it too confusing. This is basically the triangle ABC, and there's a center inscribed inside with the center O. And then they're saying that there's another circle that passes through AOC. So, how am I going to draw that? So I guess I'm just going to draw part of it. So I guess something like this, where it kind of goes through A, O, and C like that. And you guys understand. Okay, great. So let's see what we can do here. That's a relatively decent diagram. So where do I go from here? I'm not really sure. So I'm going to first just, without making the diagram too messy, I'm going to draw it again, but just half of it. So this is A and this is C. And because it's equilateral, we know that's 60, this is 90, and that's 30. So that's good at least. And we don't really know much more than that at this point. But we do know that the side length is 6. Okay, so that I can put 6s everywhere like that. I think it will be beneficial if we try to put a radius on that triangle. And because the question tells me that the circle passes through A and C, we can actually connect the center to A and C like that, and those will represent the radius of that larger circle. And then we basically have the circumradius formula to help us out, and that says the following, that 2 times the radius is equal to, in this case, the chord AC all over the angle, the sine of the angle AOC, because it touches the circle there as well. So if we were to draw that like that, this angle right here. Now that angle should be relatively easy to figure out, because this line here from A to O is straight down. So if we go straight down all the way to the bottom, this is a perpendicular. So that means this is 30, since that whole thing was 60. And in a very similar way, that's 30 as well. So that means that this angle in here is 120, that angle being AOC. So really what we have is 2R is equal to AC. Well, AC is 6, and the sine of 120. So hopefully that was not too confusing. And here we go. I think that's about it. So we can solve this. 2R, the sine of 120, that's one of those ones that you should remember. It's root 3 over 2. So let's solve this. This is going to be 2R is 6 over 1 times 2 over root 3. So this looks like R is equal to 6 over root 3. Multiply top and bottom by 3, and we get 6 root 3 over 3, which is 2 root 3. Okay, so that's the radius. And then what do they want? Area of the circle. Well, area of a circle is pi r squared. R in this case is 2 root 3 all squared. So we get pi times 4 times 3, so 12 pi. Okay, I'm convinced, and that would be B. Problem number 10. What is the sum of all possible values of t between 0 and 360 such that the triangle in the coordinate plane, whose vertices are cos 40, sine 40, cos 60, sine 60, and cos t, sine t, is isosceles? Okay, So the first thing I'm going to need to do is draw a little diagram here. All right, so first let's plot what they gave us, which is the only ones they gave us, which is this guy and this guy. So cos 40 sine 40, that's going to be, well, approximately here, right? So we got cos 40 sine 40. And I'm assuming you guys know how to plot these. If you don't, just review it. It's actually pretty straightforward. And then cos 60 sine 60 is approximately there. And there you go. Cos 60 sine 60. And we'll call one A. And we'll call this guy A. And we'll call this one B. Okay? And then this one we'll call C. So what they're saying is they want you to figure out what would be the values of T to make the triangle ABC isosceles. So if a triangle is isosceles, obviously, as you guys know, if two sides are the same. So the first scenario is if AB was equal to AC. AB is equal to AC. So that means that the distance from A to B would have to be the same as the distance from A to C. So that means C would be somewhere here. So that would be C. And therefore, if you're going 20 degrees from A to B, you go 20 degrees from A to C. So this would be 20. So it would be cos 20 and sine 20, right? So I hope, oops, sine 20, not sine 40, sine 20. Okay, so in that case, the T is 20 degrees. Okay, so that's the first one. The other way of making an isosceles triangle is if AB was equal to BC. So the distance from A to B is the same as distance from B to C. So that basically just means that the C would be up here somewhere. So somewhere there. And we went to go from B to A, it's 20 degrees. So to go from B to C, it would be 20 degrees. So this guy would be the cos of 80. Correct? Yeah, and the sine of 80. So that would mean that T in this case is 80. And then the final one, to make an isosceles triangle, AC would have to be equal to BC. So that means the distance from A to C would have to be the same as the distance from B to C. So the first obvious one is if that C is in the middle. And therefore the distance from A to C would be the same as the distance from B to C. And that means that this cos is 50 and sine is 50. Because it's right in the middle, right? Between 40 and 60. So that means T is 50. And then the last one is probably the trickiest one. That one is, there's one more, I think. And that is AC and BC, if it's all the way on the other side, so exactly opposite, so 50 from the origin, so that would mean this represents 180, right? So 180 plus 50, 230. Yeah, 230. So that's going to be cos 230 sine 230. And that would be the C right there, because that means that the distance from A to C, let me just draw it, would be the same as the distance from B to C, yeah, and it would be isosceles. So there, that gives me one more, and they want the sum, so they want you to add up these. So that looks like 100, 150, 380. So 380 would give me choice E for number 10.